Good evening, thanks for coming. I'm sure you guys are really hungry. I know it's late in the day, but I appreciate you guys sticking around for these last couple talks. My name is Zach. I'm a graduate of the Digipin Institute of Technology. Several years ago, I've been hopping around from studio to studio since then. Recently, I've landed at 17-bit. We made a game called Skulls of the Shogun, and now we're working on a PlayStation 4 game called Galaxy. What I'm going to talk to you guys about today, though, doesn't have anything to do with work. This is a personal project that I've been working on in my spare time. It's all about audio synthesis and using a tool called SuperCollider. So has anybody here ever heard of SuperCollider or used SuperCollider? Yes? Okay, a couple people. So what we're going to start with is a quick crash course in SuperCollider, what it is and how it works, and then I'll show you how it's been integrated into Unity. SuperCollider is a multi-platform open source audio synthesis toolkit which lets you build your own sound from scratch. It gives you an interpreted language. It's kind of similar to C, but also to Smalltalk. It has things like tail call optimization and closure and coroutines and some other fancy features that make building up these sounds really easy, or easier. It's used a lot by musicians and scientists and people who are investigating and just researching sound synthesis. The architecture is a little weird. It's run as a client-server pair, so there's always two processes running. The client is what interprets the language and sends it to SC Synth, which is a super heavyweight process that does all the number crunching and spits out the results. And this is, it's connected using something called Open Sound Control, which is a messaging format that is kind of similar to MIDI, had some more features than MIDI does. But it can be run over a network, so you can have your synthesizer app or process running on one computer and SC Lang running on a different computer, and the two can talk to each other. It also means that you can replace SC Lang with something else, and we'll get to that a little bit later. So SuperCollider uses a family of objects called UGens, which stand for unit generators. And just to familiarize you guys with what it looks like, this is a sample of some syntax in SC Lang. This line of code will make two oscillating sine waves playing in the left and right channels, slightly detuned. That first parameter, the 440 and 442, is the frequency, and so these will sound a little bit out of tune, just enough to give that sound some depth in your ears. And if you consult the SuperCollider documentation, you'll find that the sine-osc unit generator takes 4 parameters, and those are listed up there. So there's frequency, phase, multiplier, and addition, and the mole of 0.2 just brings that audio down, so it's not quite as loud. A unit generator is anything that processes or generates a signal, and so it's not just audio. It can be used in a bunch of different ways. And you'll notice that we're not actually calling sine-osc, we're calling sine-osc.ar. AR stands for audio rate, and it has a complementary sibling called KR, which stands for control rate. I think it'd be CR, but it's KR. Control rate signals are sampled less frequently than AR, and so they're better suited for modulating a signal than generating audio. And so synth-defs are a step above UGens. A synth-def is a collection of UGens. Here's a simple synth-def definition. This one's called simple sine, and as you can see, it takes a sine-osc UGen and a list of arguments. That frequency argument means that you can tweak it after the synth-def has been created. The syntax for simple sine is kind of weird. It's got a backslash. That's just a symbol. It's the same thing as enclosing it in quotation marks. And there's one more snippet in there, that out.ar. Out is another unit generator, and out just spits all that out to an audio buffer, and by default, that's the audio hardware, so it just comes out of your speakers. And once you have a synth-def, you can make a synthesizer from that synth-def by instantiating it. Synths can be started or stopped, but you can also tweak parameters after it's been created. So this is analogous to soldering some components to a board. You can't change the layout once that synth-def has been created, but you can tweak knobs and tune it to get a different sound. And here's how you would do that in SuperCollider. Super simple. So that's pretty much SuperCollider in a nutshell. There's over 250 different unit generators, and those include filters, delays, envelopes, and all these things And it's a huge library of building blocks for constructing all sorts of different sounds. You can make almost anything that you can imagine, but it comes at a cost. One is that there's a huge investment of learning the language, because it's its own programming language, and you have to know the syntax and how to use it, and you have to familiarize yourself with all of those unit generators. And like any programming language, you can make syntax errors, you can have logic errors, and it'll crash or not do what you expected it to do. And tweaking your synth on the fly is difficult. I know it's said it's kind of easy because you can expose parameters like the frequency and all those things, but to change them, you have to type in code, you have to run the code and see how it looks, so it's not quite as dynamic as it could be. There's also not a unified GUI. It has a GUI system, but the GUIs are document specific and they're non-generative, which means that you can't use a GUI to build a synthesizer. So it's limited in what it can do. And also, it looks like crap. And the question that I wanted to answer was, how would I use SuperCollider in a game? I mean, I can render out these sounds, I can make them from scratch, but then what do? I'd have to save them as waves. I could do something like what Trevor did, and I could assemble them piece by piece. But for the game that I have in mind, that's not really what I want to do. So I set about trying to bridge the gap between SuperCollider and Unity, because I thought that maybe they could work together. As I said earlier, SC synth can be controlled by other applications, not just SC lang. The problem, though, is that to do that, it requires a lot of bookkeeping. You have to basically rewrite most of what SC lang does. But it does 95% of the work that we need it to, so why don't we just build on top instead of starting from scratch? And so the goal for me was to make a tool that would let me generate synthesizer definitions in SuperCollider in an intuitive and easy way, and hopefully inside of Unity. And Unity is used a lot for games, but it has so many other applications besides games. Their editor API is pretty full-featured and can do a lot of stuff. You can use the system.NET assembly to send OSC messages. OSC messages transport over UDP or TCP, so you can send them across the network or inside your own local network. And if we do this all inside Unity, then we could conceivably use it in your game. So let's go back a little bit and revisit Open Sound Control. Open Sound Control is usually referred to as MIDI 2.0 because it's similar in concept in what it tries to do, but it does it better in almost every way. It offers higher resolution values. So with MIDI, all of the data that you send across is 1 byte, which is 8 bits. So at most you have 0 to 256 integer values, and that's enough for a lot of applications, but not as much as you'd like in some cases. And Open Sound Control lets you send across strings, floats, bools, and all sorts of more complex data types. So you automatically have a much higher resolution in terms of what data you can send. Like I said before, you can transmit it over the internet or over a network really easily. With a URL style naming scheme, you can address devices specifically. So you could say /Zack station /synth5 /frequency, and that message will go directly to whatever is listening for that. And by using pattern matching, you can also specify multiple recipients. So OSC is super flexible and can be used in a lot of different ways. But specifically in Unity, you can write your own implementation from scratch. The standard is really well documented, but I was really impatient, and so I chose to use a third-party OSC library that you can find here. I'll put a link to it up at the end, so don't worry about writing it down. But this handles almost everything you would need to send or receive OSC messages through Unity, except for packet bundles, and that wasn't really a concern. So when thinking about this tool that I wanted to build, I really wanted to make a node-based graph editor for a long time. I'm really into tools programming, and I just love this aesthetic with windows and Bezier curves, and I just think it looks really cool, and this seemed like a perfect fit for the technology. And so this image really just depicts two key elements in the Unity editor. One is a sub-window, and sub-windows are pop-up windows called by GUI.window. They float above everything else. You click to focus them, they can be dragged around, but they're not resizable, which kind of sucks, but it's not a big deal. And Bezier curves don't come out of the box with Unity, but there's a script up on the Unify wiki that will draw curved lines. And it didn't work out of the box. I had to make some fixes, but I fixed the bugs and put the uploaded or updated version back online. And you can grab that at the Unity wiki, or sorry, Unify wiki. And so with those two components and a little bit more editor scripting, I was able to come up with this, which is a bunch of different unit generators represented in the editor, all connected together. And it looks like a lot of GUI code, but it's not actually. Most of the unit generators you saw just expose a few fields, and then the editor knows how to get data about those and then populate it with controls automatically. So you're not writing hundreds and hundreds of lines of GUI code, you're letting the editor do most of the work automatically. This is the unit generator representation inside of Unity. It's actually more legible than I thought it would be. Unit generators have an ID, so every one that you make is unique. There's a list of outputs, so that a unit generator can output a signal to all sorts of different nodes. It has some modifiers. There's a flag for audio rate versus control rate. And then there are two methods that every unit generator needs to implement, and that's get definition and get args. You'll notice in this last slide that there's no inputs. There's no frequency phase, multiplier addition, and that's because every derived unit generator adds those itself, and it uses some custom attributes so that the editor knows how to pull data from that. I don't want to get too much into reflection because it's kind of a deep topic, but you can look at more about reflection and custom attributes if you like. And all these input fields can be either a float or reference another unit generator in the graph. And so because of that, I had to make a custom class for UGen inputs. Like I said, getArgs is one of those methods that every unit generator has to implement. It's just a list of all the parameters for that unit generator that you can tweak. And the other one is getDefinition. GetDefinition is the code that SuperCollider will execute to make this unit generator. Because basically what we're doing is we're building a string representation of our synth, sending it over to SuperCollider, and then letting it do all the heavy work. And for the sign generator, it looks like this. It's just the UGen call, and then it takes in all the arguments that we defined earlier. Oh, and if the UGen input is being fed into from another unit generator, then it just pulls that node ID and sticks it in place of the argument. And that's how things get chained together. And so once this graph is all assembled, we start at the very, very end and walk backwards and push all of these unit generators onto a queue. And then we walk it from the front to the back, and we concatenate all the strings. And that sounds kind of complicated, but when you see the output, it looks like this. And this is actually taken straight from that image I showed earlier. This is all four of those nodes and all their interconnections in a format that SuperCollider knows how to handle and can process. So we have this synth definition, but SC-lang doesn't know what to do with it. We have this string, and it doesn't, what's it going to do when we send it to it? But fortunately, it gives us some methods for writing our own OSC receiver functions inside of SuperCollider. So we can send and receive data from Unity or to Unity. And that is most of the explanation. So I'm just going to jump right into the demo. We're going to build a synthesizer from scratch, which is going to be really cool. This is SuperCollider. SuperCollider has an IDE, so it takes care of the two processes I talked about. So SC-lang and the SC synth both exist inside this program. So it takes care of all that for you. This file that I have open is synth graph responder. It's a proxy script that I wrote, and it's what handles sending and receiving OSC data from into Unity. So first we're going to boot up the server. Running these 4 lines of code just tells the server to boot, clears the environment, and gets it ready for use. And then this function down here gets added as a OSC receiver. And it's what knows how to add a synth definition, how to play a synthesizer, how to stop one, and how to tweak its arguments on the fly. So we will select all this and run it. And now SuperCollider is ready for input from Unity. so we're going to, like I said, start from scratch. We'll make a new game object and add one of our synth graph components and edit it in the editor. And every synth graph starts with an output, which is just this little green box. Can you guys see that okay? Is that coming through? Okay. So we can right-click and add a new unit generator. This is still super experimental. I only have 7 or 8 different unit generators. But let's throw a sine wave in there just to see how it sounds. You need to be running so that Unity can send OSC data. Can send OSC data to SuperCollider. So we'll connect the output of the sine wave to the output bus, and then send will send that definition over to SuperCollider. Actually, before we do that, let me turn down the volume so it's not so loud. So we send the definition and hit play. Okay, it's a sine wave. It's not that exciting. Hold your applause. It actually sounds kind of bad. It's really uninteresting. It's just a sine wave. Although once it's playing, we can change its frequency, which is kind of cool. Offset its phase, so it starts sooner or later. And multiplication and add really just affect the strength of the signal, the volume, so we don't really want to mess with those too much. All right, well, let's try something besides a sine wave. We'll leave that aside for now. Let's try a pulse oscillator, pulse wave. So we'll hook up the output. And again, turn down mul so it doesn't blow the speakers. Hit play. Whoops. And send. Okay, it's a little more tinny. That's really even worse. But what we can do is we can add an envelope. I don't know if you guys are familiar with the concept of envelopes, but envelopes give you a way to control the amplitude of a sound over time. And triangle one is really simple. It's just imagine a straight triangle. It starts at 0, goes to some max amplitude, and then goes back down to 0. And that's what this unit generator gives us. So it gives us a duration, which we'll leave it 1 for now, and a max amplitude, which we'll set at about 3. And then we can hook this up to the multiplier input for the pulse. So now when we play it, it comes in and goes back out again. So it doesn't just keep playing over and over. That's cool on its own, but we want to be able to control the frequency. We want to control the pitch. We want to make sounds that are not just 440 hertz. So I actually made this on the bus on the right up here. This was about to be a really boring presentation because it was just going to be that sine wave, and then I added the keyboard. The keyboard changes everything. So the keyboard changes the frequency parameter to whatever key you press. So now we get actual notes, which is super cool. And those are a little long, so if we turn down the duration of the triangle envelope, we get something really short. It actually sounds kind of like a synthesizer. And I've got these mapped to keyboard keys, so if you hear sounds and I'm not clicking stuff, it's not magic, it's just this. We can do some other things too. We can, we can oscillate the width of the pulse width modulation, which gives us an even more interesting sound. So let's have a simple sine wave. Sine waves are great because they give you a nice, steady, constant signal. But we don't want it oscillating at 440 hertz. That's way, way too fast. We want something like maybe once a second, because we're only going to be hearing the sound for 0.2 seconds. So let's try something a little more within normal range. Not bad. Pretty cool. And again, just by futzing with this value, we can get even more interesting sounds. Cool. So that's as far as I've gotten. I've only added a few unit generators, and this is still really early on. But like I said, there's 250, and they don't take a lot of time to add, so I'm just going to keep adding unit generators and see where it goes. Okay, so that was kind of cool, but there's other stuff that I'd really like to add before before doing anything serious with it. The first step is filters. Subtractive synthesis really needs filters. Filters are the bread and butter of subtractive synthesis because you start with a big block of sound and you use filters to carve away the frequencies that you don't want. The unwanted frequencies get tossed aside. And like a low-pass filter, high-pass filter, I'm sure you guys have heard of those. Those are probably the next thing I'm going to implement in this tool. Better support for envelopes. Unity's animation curve editor would be perfect for doing a sort of attack, sustain, decay, release envelope. Just setting a few control points and you can get more control over that sound instead of just the simple triangle up and down. This is slightly more complicated, but I think critical for SuperCollider to really work well with Unity, and that's to route the audio output. Because right now all the audio is playing from SuperCollider, it's not playing from Unity. And by outputting all this audio to a buffer instead of to the audio hardware, we could have SuperCollider route that audio data back to Unity and then implement the on-audio filter read function on an audio source, which basically gives you a way of filling an audio buffer with whatever you want. So you could just pipe this data right into Unity, and then you have spatialized sound, and you can take advantage of all the other parts of Unity's audio system. Keyboards, I have a virtual one already, thanks to the Bolt bus. And MIDI would be another good thing to have for composers. Also a sequencer would be great. I forgot to add that to the list, but a sequencer would be super great. And automatic initialization of SC Lang and SC Synth. So right now I had to boot up SuperCollider, run the script, and then I could do things in Unity. And that process really should be automated if you want to ship this or give it away to people who don't know how to go through this process. You may have heard of Pure Data before. Pure Data is another synthesis toolkit. It has a much less restrictive license. You can do a lot more with it commercially than you can with SuperCollider. SuperCollider is really geared more towards people who are researching audio. It's inherently more visual. It's not a programming language. You're actually connecting blocks. You can build it as a plugin. Covered that already. And Fract OSC. I don't know if you guys have seen Fract. I love that game. It's sweet. It's easily my most anticipated game of next year, and they're using Pure Data. And they're also using Unity. So this is Unity and Pure Data is a relationship that's been proven to work. Reasons you might want to use SuperCollider instead is that you only need to send OSC messages. You don't need to build a plugin. So anybody who has Unity can use this. You don't need a pro version. You can do it with free. Audio processing can be done on different machines, so you could set up a SuperCollider server on your home machine and tell your friend to play the game, and they would send all their messages to your machine, and it would process it and send it back. So that way you can divvy up the workload if you need to. You could also have multiple clients interact with the same server. So again, if the server's on your home machine, you could have 10 people who are using your machine to generate all that audio. It also works on the web player. I know that plugins don't really work that well in the web player, so this is another reason why SuperCollider might be a good choice. There are some reasons you don't want to use it or might not want to use it. The GPL is incredibly restrictive. Basically, if you link your project against code that uses the GPL, then your code has to be under the GPL. So you basically have to give away your source code for free, which you probably don't want to do if you're trying to make money off of it. Having multiple points of contact heightens the risk of failure, and what I mean by that is that there's a lot of places for SuperCollider to fail along the way. So the connection between SC Lang and SC Synth could fall apart. The connection between Unity and SC Lang could fall apart. There's a lot of places where things can go wrong. And then when something does go wrong, what do you do to fix it? What happens if SC Synth just stops working? You can't easily boot out of it, and that can be a problem. Is there another slide? Oh, and here I just go into a little bit of, detail about the GPL, but I think I'm going to skip over that. It's basically what I said before. If you link your code to it, you need to include your code under the GPL. Okay, and that's it. That's all I've got. Here's all the links that I showed you guys before. This first website up here, synth.tk, is super, super valuable if you have any interest in audio synthesis. The guy really seems to like subtractive synthesis as opposed to granular or additive, but it's presented in a really, really easy to understand format. And I don't know a whole lot about audio synthesis myself, but just from reading his articles and tutorials, it's been really eye-opening. So I wholeheartedly recommend you check that out. And if you would like to check out the project when I release it, it's going to be open source, so people can contribute to it and check it out. You can check out my GitHub, or follow me on Twitter, or send me an email, and I'll announce it on all 3 of those channels when it's ready. And that's all I've got. So if you guys have any questions, happy to answer them. Thanks. Nope. Yeah, one. Do you mind going up to the mic? Sorry.
It was kind of far away. So when you started the project, like what your intentions were, what you wanted to use it for?
So there's a game that I've been wanting to make for a really long time, like 5 years. But up until recently, the technology, at least on Unity, wasn't really ready for it. And it's I'll just tell you guys, it's a. Anybody played Beat Farmer? Or sorry, not Beat Farmer. The game is called Beat Farmer. Anybody played Harvest Moon, farming simulator? The game I want to make combines that with a synthesizer. So basically you're building your own music by planting seeds, harvesting them, doing all this stuff. And I really wanted fine control over building up an instrument. So this is what sort of sparked the whole idea. Get one more.
Hey. Does SuperCollider support additive or FM synth?
Yeah, absolutely.
It does?
Yeah.
Okay. Yeah. Can your original sample, sound wave, be taken from a sample?
Yes, it can. So in SuperCollider, it's easy to do. You just give it the path. I haven't quite reasoned out how to do it in Unity. You could maybe take an audio clip and then send that PCM data over to SuperCollider and use that as a sample. I'm not sure what the best approach is yet, but it's definitely something that SuperCollider can do.
Cool. Sounds good.
Yeah.
I don't know if this is what he was asking, but what's going to be your path to integrate SuperCollider into your game so that you can just download from the asset store or whatever and not have to run that SuperCollider IDE?
Right. So you don't need to use the IDE. You can just run sclang and scSynth as processes, and you can do that from Unity. You can start a process in the background. So it's just a matter of starting them up, having some scripts that you immediately pipe into it so that you can start sending stuff back and forth from Unity. It's something I've looked at briefly. I spent a couple of hours investigating it, but I haven't really solved that problem yet.
Would that keep you from having to press that syn button every time you change a parameter?
Not every time you change something, every time you add a new node. And that's only because, I mean, it would be easy enough to have that automated so that anytime you add a new node to the graph, it automatically sends over the definition.
Okay, then my last question was, you said there were 250 something,
yeah, there's a lot. 250
what?
Oh, unit generators in SuperCollider. So like a sine oscillator is a unit generator, a saw wave, pulse width, filters, delays, triggers, all these other things are all individual chunks that you can chain together. And that's what there's 250 of.
And then last question, did you set up like a blog where we can go there and chat about this and get on your GitHub and stuff?
No, I don't. I have a blog, but I don't really update it that often. So shoot me an email or on Twitter or something. I think that's it. Okay, great, thanks.